Hello guys. So today we'll continue with question number 5 for this paper. And so the question says a piece of wire of length 24 centimeters is bent to form the perimeter of a sector of a circle of radius r centimeter. So that show that the area of the sector a centimeter squared is given by a is equal to 12r minus r squared. So the first step here is to express the area of the circle, the area of the sector of the circle. That will be the area will be equal to theta, which is the angle in radians for the whole circle. So theta divided by 2 pi, and that all that multiplied by pi r squared. So the area of the entire circle is pi r squared, and the area of a sector is the angle in radians per 2 pi. So it's a proportion of the circle out of the whole circle and multiplied by the area of the whole circle. So now that we've gotten that out of the way, the next step is to use the information that is in the question. So a piece of wire. So let's just jot down that information. The length of the wire is 24 centimeters. And the next step now is to look up the next piece of the information, and it's bent to form a perimeter of a sector of radius r centimeter. Okay, so now the next step is to express this in terms of the perimeter of the sector. So this will be the perimeter of the circle will be theta over 2 pi, as we talked about before, multiplied by the perimeter of the whole circle. So that is 2 pi r. Okay, and from here we can see that the 2 pi cancel, so you get theta times r, which is the radius, and that is equal to 24 centimeters. So this is our first equation. So theta times r is equal to 24 centimeters. And now now we use the equation that we formed previously. So let's simplify that equation first. So here we have the pi cancels. So we have theta r squared divided by 2, and that's equal to the area. So we let's rewrite that. Area is equal to theta r squared divided by 2. We have the information from this equation right here, in that theta is equal to 24 divided by r. And why do we do this? Because the question says we have to show that area is equal to 12r minus r squared. And right now in this equation that we have both r and theta as um, the terms, and we don't want that. What we need to do is to input this theta into this equation. I made a mistake apparently. Now, okay, so let's rewind a bit. I'm sorry for this, because I am also doing this at the same time. This is actually the first time I'm doing this as I'm explaining. So I misread the question. The perimeter of it's not the perimeter of the sector itself. So if you have the sector of a circle, if you have the sector of the circle, I thought it was this part only, but apparently it also counts this sides as well. So you have the perimeter, not 24. So let's go back. So the perimeter is not simply this. It is also the plus 2r, because yeah, this part right here is the first term. So that is theta over 2 pi times 2 pi r, but you have plus r, so you get 2r. So really, if you substituting the numbers, that is 24 divided is equal to theta times r plus 2r. Okay, now this is pretty sure this is a correct equation. And as we talked about, we make theta the subject, and this will be 24 divided by uh, is that right? That's 24 minus 2r, divided by r. Okay, and now we plug this theta into the theta that was in the area before. So area is equal to, now we substitute it in 24 minus 2r divided by r times r, squared over 2. So the r squared cancels with r, so that becomes r, and that becomes 1. And let's go to the next page. So we have 24 minus 2r divided by 2 times r, and this simplifies to 12 minus r times r. And let's see if we have that correct. Actually, it's, yeah, nearly there actually. So that's 12r minus r squared. And so we have answered the first question. Sorry for the first mistake, misread the question there. And uh, so in the second part of the question, we have express a in form of a minus r minus b squared, where a and b are constants. Okay, so there's a little formula that I like to use here. So if you have any expression that is a x squared plus b x plus c, and this is equivalent to a, and into bracket, that is x plus b over a, x and all that squared. mm, okay, and so let me just write it down there because this I need more space. So that is equal to a x, so that's not x squared, that's x plus b over a x squared, I'm sorry, just b over a all squared minus b x. So that actually that's just b minus b, let me just make sure that, okay, yeah, b squared over a squared, and that is uh, plus c. Okay, and if you expand this out, you will get the same form. You're welcome to do so, but I'm sure you can do that. So let me just say that verbally. So if you expand this part, so that's x squared plus bx over a plus bx over a, that's 2bx over a. Duh, okay, this is 2, now that makes sense. 2 and 4, yes. So bx over 2a plus bx over 2a, that's bx over a, and you get plus b squared over 4a squared. Hence that's why you have this term right here to cancel out with that term. Okay, so yeah, this is the general formula that I like to use. I don't know if somebody has it, but I made it myself. So now we have the equation that we have here, and here in this equation you have a is equal to minus r squared plus 12r plus 0. In this case, a is equal to 1 minus 1, sorry, and b is equal to 12, and c is equal to 0. And plugging that into the equation right here. And don't confuse the a's and the b's and the c's as here and the ones in the equations, they're not the same, a and b and c. I'm just using this for my own purposes. So anyways, so plugging this into this equation right here, so that is minus 1, or just minus x plus b, that's 12 over 2a minus 2 and all that squared. And now it is minus b squared, that is 12 squared divided by 4 minus 1 all squared, and that is plus 0. Okay, let me just erase these equations above. So if you expand that, that will give minus x plus 12. Oh, that's minus 6 then. That's minus 6. Sorry, minus 6 plus squared plus 144 divided by 4, and that will give, that's 144 divided by 4, and that is that's 3, and that's 12, 2, 4, and that's 36. Yes, 36 plus 36. Okay, and so so finally the answer will be that the area 30 is equal to 36 minus x minus 6 squared. And you can expand this and just to make sure that that's correct. For example, you can have 36 minus that's x squared minus or plus 12x plus 36 minus 36, and minus 36 cancel with this, and you have the original equations. Well, instead of x, that's actually just r, not x. So this is your final answer for part 2. And now part 3, it says, given that r can vary, state the greatest value of a and find the corresponding angle of the sector. And so in this equation, it is a maxima minima problem. If you can draw or graph, but you are not allowed a graphic calculator. I don't think so. But you can imagine what this would look like. So sorry. So if you have this is an r and this is a, and the negative coefficient of the square term, that means that this will be in this form, and the maximum area will be this, where dA over dr is equal to 0. That means that the rate of change of a to the radius is 0, and this point here is what you're looking for. And one way, there's several ways to go about it, but the one way that I like to use, because it's very simple, is to use differentiation method. So we established that dA over dr is equal to 0. So that's just differentiate that with respect to r. That is 36, that becomes 0, minus 2 times r minus 6 times 1. Chain rule. I hope you know how to do this. Okay. If you don't, email me and I will answer those. I will probably create a video answer just specifically to those problems. But I think you know how to do this. So you have dA over dr is equal to minus 2 r minus 6. Okay, and we equal that to 0. We equate that to 0, and that means that the r is equal to 6. That is 6 centimeters. Okay, and if we plug that into the original equations for a, and that is just 36, because if you plug that into the equation, the r is equal to 6 minus 6, that's 0, so the maximum area is 36 centimeters squared, and the radius for that is 6 centimeters. Okay, and they ask, find the corresponding angle of the sector. Oh, that actually goes back to the original equation, and that equation will be this equation, or just the more tidy, yeah, this equation right here. This is the equation we're looking for. So you have 6, we plug 6 into this, that's just 6, and that's 6. So that is theta is equal to 24. Theta is equal to 24 minus 2 times 6 divided by 6. So that is 24 minus 12, that's 12. And 24 minus 12, that's 12 divided by 6, that's 2 radians, not degrees, 2 radians. Okay, and whenever you're working with this kind of problem, try to use radians and rather than degrees, because otherwise you'll get 32 radians, that's 300 degrees or something, so that will be very weird. 300 plus 300 minus 2, anyways, try to use radians. So final answer, area is 36 centimeters squared at the angle theta of 2 radians. Okay, and let's check the answer to make sure that we are correct. So that it will be in my documents, and that is question 5. Okay, okay, so first part correct, and so there we have it. uh, so that's all for this question, and thank you for watching. I'll see you next time for question number 6.